And welcome to the Daily Space Weather. Lots of stuff to cover today, including a coronal mass ejection warning and a new Sunspot 2835. And the first thing we're showing here is the coronal mass ejection warning graphics. This is the viewpoint from Stereo A, a spacecraft which trails the Earth. And from the perspective of Stereo A, Earth would be off to your right. So our channel has a tendency to forecast coronal mass ejections before they leave the solar corona. And here's the viewpoint. This is Stereo A located at Lagrangian point 5. So Earth would be off to your right from this sort of viewpoint. And you can see there's a large plume of plasma there. The ejection of that is imminent. Some of it may collapse back onto the solar corona or even into the chromosphere, but some of that plasma will become a coronal mass ejection. Will it be Earth-facing? Well, it's too early to see that. Let's take a look at some imagery. This is 1700 angstroms and 335 angstroms as a composite. You can see up in the upper right, that's Sunspot 2833 setting. Down in the lower left, that's Sunspot 2835 rising. This bright region here is just a plage, no sunspot associated with that area. Here is Sunspot 2833. It's going to lose its name today as it will be out of view of the Earth-facing zone. And it looks like a minor flare just happened there, actually. Right at the end of the video, a little bit of plasma kicking up there. And here's the rising of Sunspot 2835. More close-ups of that at the end of the video. Again, lots of stuff to cover today. And here's what's going on in the solar system. Another interesting story about that as well. Anyway, let's advance this 1 week. There's where things will be in 1 week on July 2nd. Here's a star chart. I use in-the-sky.org. I face my star chart to the south, and I draw in the ecliptic. If you're up before dawn, you may see the Moon, Saturn, and Jupiter up there. And the 10.7 centimeter radial flux now down to 80. Here's a 1-year chart of the radial flux. It's this black line, the most proportional data set to sunspot number in terms of solar activity. NOAA did issue a warning, and our patrons would already have known about that if they were checking patron posts. Patreon.com/smashamash. Thanks to our patrons, the true source of funding for the content. Being a patron provides you with all sorts of perks that nobody else gets. Multimedia, early warnings, and all kinds of other analysis and science data nobody else in the world gets to see. Patreon.com/smashamash if you'd like to help support our efforts. Thanks again to our patrons. And Patreon helps us out a lot as it gives us some insight into what our income will be. So here is the 193 angstroms full disk view from the Solar Dynamics Observatory. This is ionized iron. And the NOAA alert must be for a coronal hole wind stream. Anyway, NOAA forecasting geomagnetic unrest, a KP of 4, no time frame on it yet, divulged. And let's get into the world of seismicity. We're seeing a lull, a drought of 7+ magnitude earthquakes. There's the 90-day bar graph. You can see how few 7 magnitude earthquakes we saw in the last 90 days. Historically, we see a lot more 7+ magnitude quakes than that, as you can see from all of those red bars on previous graphs. It's an earthquake drought. So here are the 5 magnitude quakes of the past 24 hours. It looks like 4 of them, as reported by Volcano Discovery, a 5.5 near New Zealand, 1 in the middle of nowhere, 1 near Papua New Guinea, and 1 at Afghanistan. Let's check out the USGS list. But first, an article on phys.org about what causes foreshocks. And basically what the article is just saying is that acceleration along a fault line is what can cause foreshocks. And we're showing the article just to cite the fact that you should always note the fact that a large earthquake could be a foreshock of a larger earthquake. If you experience a 6, maybe that's a foreshock for a 7, which is 10 times as powerful as a 6. Anyway, this article from phys.org And feel free to pause the video to read the article if you like. We'll be here when you get back. It's the beauty of video on demand. So we saw some deep quakes about 24 hours ago here, such as this 4.4 at Fiji and this 4.4 at the Coronal Islands, which occurred only 10 minutes later, but at a much less deep place on Earth. So the Fijian quake here at 590 kilometers, followed by the Coronal Islands quake at 146 kilometers. Here's that 5.1 in the middle of nowhere there at the Antarctican Pacific plate boundary. Continuing on, Texas saw 2.9. New Mexico saw 3.5. All right. And I think the largest of the past 24 was this 5.4 at Papua New Guinea. If it wasn't that Afghanistan quake, let's continue up the list here. We don't want to spend too much time on anything today, as there's too much stuff to cover. So make sure you share the video with your friends and foes on social media, and help us to go full time, as we've got a lot of things to do, and we're not yet capable of doing them. How about a 5.3 at the Kermadec Islands? That one was at depth as well, 161 kilometers. And the Afghanistan quake was a 5.1 magnitude. Another deep quake at Fiji, a 4.6 magnitude at 449 kilometers. Afghanistan saw a deep quake as well. That one, a 4.1 magnitude at 204 kilometers depth. .6 in western South America. Another deep quake at Afghanistan. And an extremely shallow quake at Hawaii. Let's check out this one. It's 200 meters above sea level, sort of on the eastern flank there of Kilauea, south of Waukeleo Puna Forest Reserve. Again, at 200 meters above sea level. Another deep quake at Afghanistan. So lots of deep quakes on the list here, folks. And let's talk about the virility, the power of volcanoes. So this is Mount Agung, and Earth's mantle seems to provide clues to explain Indonesia's explosive volcanoes. So other volcanoes that are located on the same plate boundary don't seem to be as explosive as the ones at Indonesia, and it has to do with the chemical composition believed to be created by the dipping down into a subduction zone. So when the plate slides onto the other plate, it's believed that it changes the chemical composition as it's interacting with more things from the crust, and the interaction with more things from the crust causes a more volatile magma, which has more dissolved solids and gases in its solution, which makes the volcanoes more explosive. This article from SciTechDaily.com about Earth's mantle. I think there's one on phys.org as well in the Earth section. Also, the supervolcano Taupo. This is Lake Taupo on the Isle of New Zealand. And this is actually a supervolcano caldera. It's the most recent supervolcano to have erupted on planet Earth about 25,000 years ago. And earthsky.org has an article here about how perhaps it should be monitored. And there's an image of a meteor streaking over Lake Taupo. So supervolcanoes are about 1,000 times the size of a normal volcano, and they cause global-scale nuclear winter-like conditions, making the planet colder over an extended period of time. They inject all kinds of aerosols and volcanic ash and dust into the stratosphere. So this one's showing up. Do we think it's going to erupt? Not really. But there is some activity there at Taupo. And once again, I'm letting the article scroll here. If you want to read it, feel free to pause the video. And what would happen if Taupo erupted today would be unfortunate for global populations. I'll just oversimplify it by saying that and move on to the current list. So here we are, volcanodiscovery.com, Mount Etna still erupting. As explosive activity continues there, it's produced a 12,000-foot ash plume. So continuing on with a lot of significant activity there on the Isle of Sicily. Mount Merapi produced a 13,000-foot ash plume on the central Javan island of Indonesia, the archipelago. Dukono exploding on Halmahera. That's producing a 7,000-foot plume of volcanic ash. Sangay in Ecuador also exploding, 20,000-foot ash plume produced there. Revenador in the same country of Ecuador exploding, 15,000-foot ash plume there. Sabancaya, 25,000-foot ash plume as it explodes that ash plume over Peru, the country where it's located. A great reminder to not pole vault the caldera. Don't pole vault the caldera. Not everybody can be a hero of athletics like Steve Stimpak. This public service message brought to you at massive personal risk and expense by smAsho.com. Next, getting into the GOES 16 sun-facing suite of instruments, such as the X-ray detector. No major flares, although we're in a B-class range, a B X-ray output range, as there is some activity on the closest star. No strikes in the proton flux, no coronal mass ejections have yet ejected. We've just warned about it beforehand so that our viewers know about coronal mass ejections before they happen. Here's the GOES magnetometer over the past 3 days. And the Earth is in a North Pole current sheet with a South Pole current sheet rapidly arriving. So the South Pole current sheet has been accelerated a little bit here. You see this red area headed our way quite quickly. It's the top view ecliptic plane field plot. And we show it daily on the Daily Space Weather videos. This data is available in archival form. And here's a line of sight data for the same data set pretty much. This also shows you the solar magnetogram, and that blue line gives you an indication into the BZ component of the solar wind. And when you see it south like that, that indicates a positive BZ. Earth is in a North Pole current sheet. And here's a line of sight coronal hole plot. We can see some South Pole oriented coronal hole regions ahead of Sunspot 2835. Do coronal holes give us some insight into the way sunspots evolve? Well, I think they do. In any case, there's the latest image, and you can see these South Pole-oriented coronal hole areas rotating in just ahead of Sunspot 2835. There is a relationship between coronal holes and sunspots. I'm not going to get into it in today's Daily Space Weather video. We'll have to save that for a cosmology segment, as it gives us insight into stellar evolution. So here are the detected sunspot groups. Again, Sunspot 2833 will lose its name today as it sets over the northwestern limb. Sunspot 2835 will gain a name today. It's already beta class, despite it saying alpha there on the imagery. Check out global geomagnetism. It's currently at a KP of 2. KP2, the KP index, a measurement of global geomagnetism. Next, looking at real-time solar wind. Fairly uneventful here in the past 24 hours. Current solar wind density, just under 6 protons per cubic centimeter. Solar wind speed slightly elevated here. It just came up about 20 kilometers per second while we recorded the video. Current solar wind speed 422 kilometers per second. Next, looking at the geospace, a visualization of it using the space weather modeling framework. It's a geospace magnetosphere movie courtesy of University of Michigan, and it's 4 hours of data. And you can see a pretty homogeneous magnetohydrodynamic pressure here. You're looking at 0 to 1.5 nanopascals magnetohydrodynamic pressure, up to about 12 Earth diameters distance. A fairly homogeneous pressure on both sides, both the sun-facing bow shock side and the non-sun-facing magnetotail portion of the planet. A tiny uptick there from that increase in the solar wind. Next, ground magnetic perturbations, and we see some anomalies here. some toroid-like perturbations here stretching around the equator. That is not the normal state of affairs there for ground magnetic perturbations. And like the last frame, this is 4 hours of data. We show it daily since there's a polar excursion going on. We also saw a pulse here coming out of an area near the Philippines, right about here toward the end of the video. We're going to let it play through a second time since it refreshed. And you see some equatorial magnetic pulses here. That is not the normal thing we show. And there you can see that pulse right out of the Philippines region. So some little anomalies there happening in the magnetosphere. And by the way, thanks to our viewers who view on Twitch, twitch.tv/smAsho. We stream regularly there. Most of all, thanks to our YouTube subscribers. Most of our content is on YouTube. If you're watching the videos anyplace else, and you're probably not, this is a YouTube exclusive. If you're watching them anyplace else, make sure you check out YouTube. Click on playlists. There's all kinds of content you may not be aware of. And we're going to integrate a brief cosmology segment in today's daily space weather video, starting with one of the only known cosmic ray point sources, Cygnus X3, possibly the most intrinsically luminous object in the Milky Way galaxy, possibly the most intrinsically luminous object. Cygnus X3 has a jet oriented directly at us as this massive object orbits a Wolf-Rayet star. It's in an ultra-quiescent state. You can see right here, right around the 0 line, which historically speaking, that's the 16-year graph, is in a very quiescent state. And we would urge radio astronomers to take a look at Cygnus X3, preferably when it goes from X-ray quiet to X-ray loud, as there's a relationship between X-ray and radio frequency. It'll give us insight into what's going on with the jet, which is oriented directly at you. Next, taking a brief stop at apod.nasa.gov. It's some imagery of M31, Messier Object 31, otherwise known as the Andromeda Galaxy. With some kind of smokestack or ancient monolith, or what even is it? It's a chimney. Okay. Anyway, that's NASA's astronomy picture of the day, an image of a chimney pointing at M31, the Andromeda Galaxy. And that's today's cosmology segment. We kept it brief because there's too much stuff to cover. Next, in the realm of electron flux, we see some minor charging hazards here over places like the Caribbean, Central Atlantic, about to move into the Pacific, Central America, and southern Mexico. Here's the one-year chart of the electron flux reported by Solon.info, and we're in moderate levels of electron flux here. There's the 3-day chart, and that is showing you electron density, by the way. And here's the forecast. The green boxes are the forecast. The yellow diamonds are the observations. And here's the total electron content forecast visualization, showing you visually the electron density for the entire air column, all the way to a GPS handset in a geosynchronous, very high altitude orbit, all the way down to your handset. Here's a diagram of the atmosphere in terms of Van Allen belts. The Earth is surrounded by charged particles, which give us insight into the Earth's magnetic fields. Next, we'll look at the F-ionosphere layer, one slice of the atmosphere located at about 300 kilometers, and we're seeing continued anomalies here in the South Central Pacific. So right in this area right here, you're going to see some surprisingly high vibrational frequency there. Each one of these blobs of color represents a vibrational frequency. And as the ionosphere vibrates, it is in many ways, the bridge between the Earth and space. Welcome to space. You're on a planet that's in it. You're from space. Anyway, here's the latest image coming through at 7:45 Universal Time. Things looking pretty normal at that moment. And again, there's a diagram showing you temperatures and electromagnetic radiation penetration and the layers of the ionosphere like D and E and F. By the way, we did a meteorology segment today already. If you haven't checked it out, there's all kinds of warnings and stuff going on right now. Check it out. We've got playlists, youtube.com/smashamash/playlists. Here's the weather.gov map, and all of those yellow locations are tornado watches. Lots of lightning kicking off as well in the Midwest. And now we're looking at bonus features. It's the ground-based Hydrogen Alpha Solar Observatory here at El Teide, Spain, and you can see some filamentary motion up here. The coronal mass ejection that's about to happen is going to come from that area. You can see those filaments jumping around. They are barely able to remain attached to the sun right now. They will eject. Some of them will probably collapse as well. It could produce an Earth-facing coronal mass ejection. We'll be keeping you posted on that. Here's the thematic map from the GOES 16 SUVI. Massive amount of filaments there shown in that reddish-orange color, all in the Earth-facing zone. Coronal mass ejection is imminent. Next, some close-ups. I'm going to press refresh. There's Sunspot 2833 in its setting mode, and here's Sunspot 2835. It's most certainly a beta-class sunspot. There's Sunspot 2833 Alpha Class, and Sunspot 2835, certainly opposite polarity umbre there. It's a beta-class sunspot, and the likelihood of solar flares has also gone up. The likelihood of coronal mass ejection is just this side of 100%. So here's a close-up of the rising sunspot region, Sunspot 2835 and 94 angstroms. Here's 131 angstroms. Fantastic view of that brand new sunspot group. And here's 171 angstroms. Thanks for tuning into the Daily Space Weather, folks. Please don't forget to press like and subscribe. Support our channel via our links. We'll see you next time. May that solar wind be at your back.